So for problem 28, we're given this pair of parametric equations here, which I've written down. And they want us first to eliminate the parameter to obtain an equation x and y. And the way that we're going to eliminate the parameter, which is t, it's the argument of a trig function, we're going to use this identity here. So we're going to take sine squared plus cosine squared is equal to 1, because if we do that, we can get rid of the trig expressions which contain the parameter t. So I do need to square the equations. However, first I'm going to leave the sine and cosine on one side so that it's easier when we square. So for the x equation, I'm just going to bring the 1 to the left-hand side. So I have x minus 1 is equal to minus 3 sine of 4 pi t. So, and once I have this, I'm going to square both sides. So on the left-hand side, I have x minus 1 squared. And on the right-hand side, I'm going to have minus 3 squared, which is 9. So 9 times sine squared of 4 pi t. I'm going to square that. So sine squared, wait, maybe I should move this around. Sine squared of 4 pi t. So I have brought the 1 to the left-hand side, and I squared everything because now I have a sine squared term, which is what I need for my identity. And we're going to do the same for the y equation. So first I'm going to bring this 2 to the left-hand side. So we have y minus 2 is equal to 3 cosine of 4 pi t. And now I'm just going to square both sides. So the left-hand side squared becomes y minus 2 squared. 3 squared becomes 9. And cosine of 4 pi t squared becomes cosine squared. So once I have this, I'm just going to add up these two equations. So adding the left-hand side, I get x minus 1 squared plus y minus 2 squared is equal to, now I add the right-hand side. So that's going to be 9 sine squared of 4 pi t plus 9 cosine squared of 4 pi t. And lastly, what I'm going to do here is factor out the 9. So x minus 1 squared plus y minus 2 squared is going to be 9 times sine squared of 4 pi t plus cosine squared of 4 pi t. Okay, so once I have this, we can see that on the right-hand side, I have sine squared of an angle plus the cosine squared of that same angle, and it matches perfectly with our identity. So what we're going to do here is just substitute this whole thing that I've highlighted in blue with 1 because of the trig identity. So we finally are going to have the equation x minus 1 squared plus y minus 2 squared is going to be equal to 9 times 1. So that is our equation here. And so I'm just going to erase all of this so that we have some space to work. So after all of that, we were able to arrive at our equation where we have eliminated the parameter. So let me move that up. So this is the result of the equation where we have eliminated the parameter. And now we have to ask ourselves, what kind of equation is this? Well, if you compare it to the circle equation, we can see that this is going to be a circle with radius 3, because on the right-hand side we take the square root of the number. But now this is a circle where the x-coordinate, the center of it, has moved 1 unit to the right, and the y-coordinate has moved 2 units up. So the way that this is going to look like, so let me label some of these. So that's going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, and then 1, 2, 3, 4, 5. Okay, so our center, instead of being at 0, 0, x has moved 1 to the right and y has moved 2 up. So 1 to the right and 2 up. So this is our center. And now our radius is going to be 3. So let's see, we have 1, 2, 3. So we're going to hit this point, and then 1, 2, 3 here, 1, 2, 3, and then 1, 2, 3. So our circle is going to look like this. So we can say that this is a circle centered at 1, 2 with radius 3. Now we have to, we've described the curve, and now we have to indicate the positive orientation and the path that it takes. So where does this thing start? Well, let's look here at where t begins, which is the parameter, right? So t, it begins at the value of 0. So if t begins at the value of 0, we have to find the corresponding x and y point so that we know where this line or this path is going to begin. So let's plug in t is equal to 0 into these equations. So if you plug in, so I'm going to write when t is equal to 0, x is going to be 1 minus 3 times sine of 4 pi times 0. So that's going to be sine of 0, and sine of 0 is just 0. So 1 minus 3 times 0. And y is going to be 2 plus 3 times cosine of 4 pi 0, which is 0. So cosine of 0 is 1, so 2 plus 3, which therefore is going to give us the point. X is 1 minus 0, so 1, and y is going to be 2 plus 3, which is 5. So when we plug in t is equal to 0 into the x and y equations, this is what we get. We get the point 1, 5. And let me just label it here. So we're actually going to begin at the top of this circle here. So we're going to say begins at 1, 5. Okay. And now we have to describe what happens to its trajectory. In which direction is it going to go? Where does it end? So we can see that t is positive. So because the angles that we're going to evaluate are always going to be positive, we aren't going to evaluate any negative angles, which means that we're going to go counterclockwise, which is the positive direction when we're talking about angles, right? If t were negative, then we would go clockwise, but t is positive, so we're going to go this direction. So I'm going to say that and goes, it's going to go counterclockwise, and I'm just going to put here because t is greater than or equal to 0, and it goes counterclockwise. And now where does it end? Well, let's think about it. If we plug in t is equal to 1/2, which is the very end, what are the x and y equations actually going to evaluate? Well, when we plug in t is equal to 1/2, we're going to get, let me write this, x is equal to 1 minus 3 times sine of 4 pi divided by 2, because t is 1/2, which is the same thing as just sine of 2 pi. So let me write this, sine of 2 pi. So we can see that at the upper boundary of t, x is going to be evaluated at 2 pi. So 2 pi counts for a full revolution. So what this means here is that whenever we plug in 2 pi, because the argument is 4 pi t, it's always going to evaluate 2 pi. Furthermore, it means that the period then of these functions here, the period is just going to be 1/2. So for every 1/2 that you plug into the argument, it's actually evaluating as though it had gone a full revolution. And so I'm going to say here, the period is 1/2, so it goes a full revolution. So that is it. We know that we're going to begin at this point here, 1, 5, and t is always going to be positive, so it goes counterclockwise, and it goes all the way up to t is equal to 1/2, but when we plug it in, 1/2 actually evaluates 2 pi, so that means that we are going to do a full revolution counterclockwise and end back where we started. And that is it for problem 28.